Alright, so last concept of the day is that I want to talk about transformer. Right? Okay, so we know that we use electricity in our house. So, but how is electricity being transmitted from the power plant to our house? Actually, there's quite a process. First of all, inside the power plant, we have this so-called the AC generator that we have seen from the previous video. Okay, so this AC generator will rotate inside this magnetic field and create a electric current. Right, this electric current will then flow to the wire line, and before it is being carried to our house, right, it will meet this transformer. Okay, this transformer is to step up the voltage for your transmission. Right, so we step out the voltage means that my voltage increase. Yeah, why must I step up the voltage? Is because if I don't step up my voltage, this will, and the current flows for quite a distance, right? If I don't step up the voltage, means that my current will be high, and if my current is high, means that the total power loss will be high. So if I transmit electricity at high voltage, I can reduce this power loss. Okay, then after that, after the transformer step up my voltage, the electricity will flow until before it reaches our house, right, it will encounter another transformer. This transformer is to step down our voltage. Okay, because remember, the electricity on this transmission line actually has a very high voltage. Okay, so before it enters our house, the second transformer will step down the voltage. Because if they don't step down the voltage before entering our house, we are using electricity with very high voltage, and this is very dangerous. Right, so you need to step it down before entering your house. Okay, then of course step it down, then you go into our house. Right, so now we will learn what exactly is a transformer. Right, so transformer looks like this. It's a device to either step up or step down your voltage. It is made of your soft iron core that is being laminated. Right, so later I will say why is it laminated. Laminated means that it's like many sheets of soft iron being stacked instead of just one whole bunch, as a transformer. Okay, so soft iron core, the transformer basically is made of soft iron core. This is to increase your magnetic flux. Okay, magnetic flux, and of course to reduce your leakage. Yeah, remember, for your soft iron core is something like your magnetic shielding, right? The magnetic field will travel in this direction. It will not leak up. Okay, alright, so we have a primary coil and a secondary coil. Okay, for transformer to work, you must make sure that the electricity that we are dealing with is a AC, not a DC. Okay, why? Let's go here. Okay, so this is another form of transformer. So this transformer basically only have a battery source and two coils, and of course the secondary coil has a lamp. Okay, notice that when I put my coil near the secondary coil, my primary coil near the secondary coil, right, there is no current being induced at the secondary coil. But if I change this to an AC circuit, okay, so you notice that the light bulb lights up, right? Okay, maybe I just increase the number, increase the field strength. Okay, sorry. Okay, so you notice that if I change my source to an alternating current, the lamp lights up. This is due to electromagnetic induction. Remember, for electromagnetic induction to occur, you must make sure that your magnetic field is changing. If your magnetic field is not changing, it will not induce a EMF inside your secondary coil. Okay, you notice that if you look at your the field meter that measures the magnetic field is changing, keeps on changing. But if you change your AC back to your DC, the magnetic field is not zero, just that the magnetic field stays the same at 13.59. right? So this will not induce any current in the secondary coil. So that's why your transformer is very crucial that your transformer operates on the AC. Okay, so how is a current being induced inside your secondary coil? Is due to the changing magnetic field by your AC, right? Okay, because for your AC current, your AC current is moving back and forth. So this back and forth movement of your current creates a changing magnetic field. Alright, then of course the secondary coil, the secondary coil will experience a changing magnetic field, and this will induce a current inside your secondary coil and go and towards your output. Okay, the soft iron core is just to make sure that the changing magnetic field all goes to your secondary coil instead of going to the environment, right? Okay, so that's the purpose of your transformer. Okay, so let us take a look at the step-up transformer. So for your power generator, before it goes to our house, it will first encounter the first step-up transformer. Step-up transformer is to step up your voltage. For transformer, whether it's step up or step down, the purpose is to change your voltage. Yeah, okay, so when you are talking about step-up transformer, means that my voltage wants to be increased. Okay, so your primary coil, this is your primary coil and this is your secondary coil, right? So primary coil, your voltage is low. I can change it, I can do something to it to step up the voltage at your secondary coil. How do I do this? Basically, I must have use the number of turns to help me. Okay, I increase the number of turns inside my secondary coil compared to my primary coil. So primary coil only have 5 turns and my secondary coil has 20 turns. Okay, so since your power is the same, right? Power is 1000 watts and 1000 watts. So power is equal to VI. If at the primary coil your voltage is low, means that your current is high. So to compensate one another, right? Your power will be the same. Okay, so for your secondary coil, same thing, power equal to VI. If your voltage is high, means that your current is low. Okay, so that power will be the same. This is the principal conservation of energy. Your power can, assuming that it's an ideal transformer, your power must be the same before and after. Right? So that's why every time if your voltage is high, means your current will be low. Right? Okay, and yeah, so just take note of this. Okay, so primary power is equal to secondary power. Okay, so primary power is low, means that your current in your primary coil is high, and secondary power, if your voltage is high, means your secondary current is low. Okay, so let's go to step down transformer. So step down transformer is the second transformer that the electricity will encounter before entering our house. So step down, as you know, our voltage will decrease from high to low. Okay, so initially your primary coil, the current has high voltage. Okay, then you step it down, your voltage will decrease. Okay, so how do you do this? By using the number of turns to help you. Okay, so your primary coil, your number of turns is initially 50 turns. I want to step it down, so I decrease the number of turns to 10 turns. Right? Okay, so same thing, since your power is the same, right? 2000 watts and 2000 watts. At the primary coil, if your voltage is high, means your current will be low. Okay, so that your power will remain the same. For your secondary coil, for power to remain the same, your V will be low, but your current will be high. Okay, so that's the rationale between the voltage and current. Right? Okay, so that's about it for transformer. Okay, so in real life situation, there isn't a 100% ideal transformer. There will be some power loss due to 4 factors. The first factor, of course, we know is the resistance in coil. Okay, so there will be some resistance inside the coil right here. Okay, so this all the coil. So some current will be lost as heat energy. So your current will not be the same. Okay. Second will be magnetic flux leakage. So this can be reduced by your soft iron core. Soft iron core. Right. So the third will be hysteresis. Hysteresis is quite a chim word. Hysteresis basically means that because my soft iron is a so-called magnetic material, so when I switch on the current, this will cause the soft iron to become magnetic. And when I switch off the current, the soft iron will become unmagnetized, right? So this process of being magnetized and unmagnetized will generate heat. This heat energy will cause some power loss inside the transformer, right? So last but not least is your eddy current. Eddy current is something like your induced current like that. Okay, so for your AC, right, the magnetic field keeps on changing, right? So magnetic field keeps on changing means that there will be induced EMF inside your transformer, your soft iron core. Okay, so this is your transformer, and there will be some eddy current being induced. Okay, because of your changing magnetic field. So this induced current will generate heat. Okay, generate heat inside your transformer. Okay, so this generation of heat will also cause some power loss. So how do they reduce this eddy current? Is by lamination. Okay, lamination is like putting the different sheets of soft iron stacked together. This will limit the flow of eddy current within the transformer. Right, so that's why they laminate the soft iron core. Right, yeah. So this is the final thing that I want to talk about of transformer.